This is lesson 921, problem 948. So I'm going to do this problem for you two different ways. First, I'm going to solve it walking you through the questions that are asked in the book. And then I'm going to show you how we would solve it using the solving it algebraically like we did in the last problem. Okay, so problem A asks you to find the boundary point. And to do that, it asks you to solve this inequality like it is an equation. So we're going to just go and take our inequality that we had, 3 minus 2x is less than 1, and just put an equal sign in. And we're going to just solve for x. And that'll give us our boundary point. So to do that, I'm going to subtract 3 from both sides. So negative 2x equals negative 2. Divide by the number in front of the x. So I get that x equals positive 1. Okay, so that is my boundary point. That's where I'm going to put the circle on my number line. Okay, and before I do that, problem B asks us to decide if this circle that we're going to put on 1 has to be open or closed. And so when we look at our inequality that we are given, we do not have that equals to sign underneath the inequality. We just have the inequality, so that means that we're going to have an open circle on 1. Okay, so I'm going to go ahead and put my open circle on my boundary point, which we found was 1. Again, it's open because I just have this inequality. There's no equal to sign underneath it. And then part C wants us to test a point to determine where we are going to draw our arrow on our number line. Okay, so I'm going to just pick a number that is not 1, okay, a number that is not my boundary point. I'm going to pick 0 because that's a real easy number for me to test. So I'm going to pick 0. And what I'm going to do is just put that into my inequality. So remember, this was my inequality. And I'm going to just replace x with 0. And I'm going to see what happens when I solve. So I get 3 minus 0 is less than 1. And when I solve that, I get that 3 is less than 1. Now, if that was a true statement, I would put my arrow on the side of the number line where I have the 0. So I would draw it to the left there if that was a true statement. But 3 is not less than 1. So that means my solutions must lie on the other side of my boundary point. Okay, so again, if I had gotten a true statement here that 3 was less than 1, then I would have shaded in the side where the 0 was, but it wasn't true, so I'm going to shade in the other side. Okay, now if you want to solve this another way like we did in the last problem, so we can just solve this algebraically. So 3 minus 2x less than 1. Okay, so we would subtract 3 from both sides. Oh, sorry, yep, subtract 3 from both sides. So we get negative 2x is less than negative 2. Okay, and then now we're dividing by negative 2. All right, so the tricky thing with inequalities is whenever you divide or multiply by a negative number, so if this number here we're dividing by is negative, or if the number we were multiplying by was negative, we have to flip our inequality. So because we had a less than, we need to flip it to greater than. And so we get negative 2 divided by negative 2 is 1. Okay, so that's the little trick with inequalities. Whenever you divide or multiply by a negative number, you end up flipping that inequality. Okay, and so let's look what we got. We got that x is greater than 1, which is what we had on our number line here. Okay. So there you have x is greater than 1.